Hello, this is Walter Stone, and I'm the professor for Math 143, Introduction to Statistics. And I've been getting some questions about binomial distributions. And actually in our textbook for the online course, it's section 5.2. It's not 5.3, but I'm using an explanation that I am giving based on another text. But the ideas are very much the same. So what we want to be able to do in section 5.2 is we want to be able to define what a binomial probability distribution is, and we want to be able to calculate binomial probabilities and solve application problems involving binomial probabilities. So as you're working through this section, you want to keep in mind what the properties of a binomial distribution are and to solve those types of problems. I will also show you how to use the calculator when we do a sample problem. Now, a binomial distribution, so if you think of the word binomial, the prefix bi means two. So this idea of a binomial distribution, there are two possibilities. So if you think of binomial in algebra, it was a two-termed polynomial. So a binomial has to do with two outcomes. So a binomial probability distribution results from a procedure that meets the following requirements. The procedure has a fixed number of trials. The trials must be independent, so the outcome of any individual trial doesn't affect the probabilities of the other trials. So another way that kind of looks also at 4, that the probabilities must remain constant for each trial. And each trial must have outcomes classified into two categories. So we often, in general, call those categories success and failure. So just even though one might be a negative versus a positive consequence, things like that, we just want to make sure that we choose one of those outcomes to be a success. And often when we're solving a problem, we'll be able to determine what that means. So there's some notation for probability distributions. So once again, we have two possible categories for outcomes, success and failure. And the probability of a success is P, and the probability of failure is 1 minus P. So in your textbook on HLS, they don't use Q, but in some other textbooks they use Q. But because there are only two outcomes, the probabilities are complementary to each other. So you have probability of success P and probability of 1 minus P from the complements rule of probabilities. Since you have two outcomes also, the probability should add up to 1. So P plus 1 minus P is equal to 1. In our problems, N denotes the number of trials. X is the specific number of successes in N trials. So X can be any whole number between 0 and up to N. Once again, P is the probability of success. 1 minus P, or Q, is the probability of failure, and P of X denotes the probability of getting exactly X successes in N trials. So an example, do we have a binomial procedure? So suppose we're recording the genders of 250 newly born babies. So there are 250 trials, that would be N. And are there, in general, there are two genders of babies. There's female and male, so boy or girl. So there are two outcomes. We could do some research, for example, at a local hospital like Beverly Hospital. We could probably call up the maternity ward and ask research about what's the probability that a boy or a girl is born. And suppose they say, like, well, in the past year, the rate has been for girls has been 52%. So the probability that a girl is born would be 52%. The probability that a boy would be born would be 48%, because 48 plus 52 is 100%. So that would be, and also that the gender of a baby is independent of the gender of another baby, whether it's a boy or a girl. So they would be independent events. So that is the general idea behind what a binomial experiment is about. There's a binomial probability formula, and probabilities can be calculated by taking the number of trials factorial over the number of trials minus the number of successes x in those n trials factorial times x factorial, and we take p to the x times 1 minus p to the n minus x. And dealing with, this is the combinations formula you may have done in a bonus lesson. You may have looked at the combinations and calculating the number of combinations. But what is great is we have a way to work with our TI-83 or 84 calculator, and we'll be able to use that as our, the calculator evaluates the formula for us. So what I'm going to do in another video is explain that process. Okay? So I hope you have a better understanding of what a binomial situation is, and we will do a sample problem.